Physics doesn't lie, but the Pentagon does. In 2021, the United States Navy quietly killed the most powerful gun ever invented. They spent 15 years and $500 million trying to build a cannon that shoots with pure electricity. And then they gave up. They told Congress it was impossible. They said the barrels melted. They said the power supply was too big. They boxed up the future of warfare and let it gather dust in a warehouse in Virginia. But 6,000 miles away in a secret lab in Tokyo, someone wasn't listening. While the US was writing eulogies for the railgun, Japan was fixing it. And in late 2023, the Japan Maritime Self-Defense Force didn't just run a simulation. They put a railgun on a ship, pointed it at the ocean, and pulled the trigger. 120 shots, 0 failures. It's a story about how the world's biggest military superpower got beaten at its own game by an ally with a fraction of the budget. Today on Front Cost, we are exposing the $35,000 slug that just made China's laser army obsolete, and the embarrassing phone call the Pentagon is making to Tokyo right now to ask for their blueprints back. To understand why Japan's success is so embarrassing, you first have to understand why the American dream died. And it was a dream. In 2005, the Pentagon didn't just want a gun, they wanted a 32 megajoule monster. They demanded a cannon that could hit a target 100 miles away. That is 4 times the range of a standard battleship gun. They wanted to replace the $2 million Tomahawk missile with a $25,000 slug of tungsten. It sounded perfect. But then they met the Valley of Death. Here's the physics lesson the Navy learned the hard way. When you shove millions of amps of electricity into 2 metal rails to push a projectile to Mach 7, you don't just get speed, you get plasma. The air inside the barrel turns into superheated gas hotter than the surface of the sun. This plasma acts like a blowtorch. Every time the US Navy fired their prototype, the gun literally ate itself alive. The barrels were being gouged out after just less than 50 shots. Imagine buying a rifle that you have to throw in the trash after emptying 1 magazine. And then there was the power bill. The American design was so massive it needed 25 megawatts of instantaneous power. To put that in perspective, you would need an entire city block's worth of batteries or a dedicated nuclear reactor just to keep the gun hungry. The Navy built the Zumwalt-class destroyer specifically to carry this gun, but when the gun failed, they were left with a $4 billion ship that had no bullets. So in 2021, the accountants looked at the melted barrels, looked at the $500 million receipt, and pulled the plug. The US railgun was officially dead, or so they thought. Enter ATLA, Japan's defense research agency. When they looked at the wreckage of the American program, they realized the US Navy hadn't failed at physics, they had failed at scaling. The Americans tried to build a 155mm artillery replacement right out of the gate. Japan went the other way. They didn't try to build a Ferrari, they built a Toyota. The difference comes down to a specific number, 320 grams. The US Navy was trying to accelerate a massive 20-kilogram slug to Mach 7. To move that much mass, you need millions of amps of current, which generates temperatures hotter than the surface of the sun inside the barrel. It's unsustainable. Japan downsized the projectile to just 40 millimeters, a steel dart weighing roughly 320 grams. By dropping the mass by 98%, they drastically reduced the electrical current required to hit hypersonic speeds. Less current means less heat. Less heat means the barrel doesn't melt. It is simple Newtonian physics. Force equals mass times acceleration. Japan just lowered the mass. But reducing the weight wasn't enough. They had to fix the erosion. When a railgun fires, the electrical arc creates plasma gouging that eats the rails. The US used standard conductive materials that degraded after 20 shots. According to leaked procurement data, Japanese engineers switched to a specialized copper-tungsten alloy with high arc resistance. But they went further. Unlike the passive cooling of early prototypes, the Japanese system reportedly utilizes active liquid cooling loops integrated directly into the rail housing. The result is statistically absurd. While the US system destroyed itself after a few dozen rounds, the Japanese prototype on the JS Asuka fired 120 rounds in a single test cycle with 0 loss in muzzle velocity. They turned a science experiment into a machine gun. However, the most embarrassing innovation for the Pentagon isn't the gun, it's the battery. The US Navy assumed you needed a nuclear-class power plant to run a railgun, leading to the $4 billion Zumwalt destroyer disaster. Japan solved this with chemistry. They are the first nation to utilize gallium oxide, Ga2O3 power semiconductors in their capacitor banks. Gallium oxide can handle significantly higher voltages and switch faster than standard silicon or silicon carbide chips used by the US. This allowed Japan to shrink the power supply footprint by 50%. This miniaturization led to the ultimate logistical flex, the 20-foot ISO container. The entire power plant, banks of 5 megajoule capacitors, fits inside standard shipping containers. This is the modular fleet concept. You don't need to design a ship around the gun. You can crane these white boxes onto the deck of a standard Mogami-class frigate, bolt down the turret, and you have a hypersonic missile interceptor in 48 hours. The US spent 15 years trying to build the perfect ship. Japan just built a better battery. Why does Japan need this weapon now? Because across the water, China is betting its entire naval future on light. Beijing has recently rolled out the LY-1 laser, a truck-mounted directed energy weapon that claims an output of 250 kilowatts. On paper, it sounds unbeatable. Infinite ammo, speed of light engagement, and a cost per shot of roughly $1. But China's engineers are ignoring a fatal variable that Japanese physicists have weaponized, the atmosphere. Here is the data point Beijing doesn't want you to see. Atmospheric attenuation. In the South China Sea, the average humidity is over 80%. When a high-energy laser fires through this moisture, it heats up the air molecules in its path. This creates a lens effect known as thermal blooming, which causes the laser beam to defocus and spread out. According to naval warfare simulations in heavy maritime fog, a laser beam loses approximately 30 to 50 decibels of power per kilometer. That means a 250 kilowatt laser might leave the barrel with lethal force, but by the time it travels 5 kilometers through a Pacific typhoon, it arrives at the target with the power of a laser pointer. It is a fair weather weapon in a region famous for storms. Japan's solution is brute force physics. A railgun slug is a solid 40mm rod of tungsten steel alloy. It carries no explosives. It doesn't need them. When a 320-gram object impacts a target at Mach 6.5, 2,230 meters per second, it delivers kinetic energy equivalent to roughly 8 megajoules. To put that in perspective, that is the same destructive force as a 2-pound block of TNT detonating inside the target, but delivered with the penetration power of a tank shell. Unlike a laser, this slug does not care about fog. It does not care about rain, salt spray, or thermal blooming. Whether it is a sunny day or a Category 5 hurricane, that slug arrives with 100% of its lethal energy intact. There is one final physics problem: heat shields. China's DF-17 hypersonic missiles are covered in ablative thermal tiles, designed to survive the 3,000 degrees Celsius heat of re-entry. A laser tries to kill a missile by heating it up, but a hypersonic missile is already built to resist extreme heat. You are trying to burn something that is fireproof. A railgun slug doesn't try to burn it, it shatters it. The kinetic impact creates a shockwave that instantly fragments the missile's airframe. Japan isn't trying to out-tech China. They are simply winning the physics argument. The hidden network. The gun is just the trigger man. The real terror for Beijing isn't the railgun itself. It's the invisible network guiding it. Japan isn't building a standalone weapon. They are building a hyper-defense ecosystem that connects the ocean floor to orbit. While the world watches the JS Asuka test firings, Japan has been quietly deploying the Deep Ninja, a class of autonomous underwater vehicles, AUVs, developed by Jamstec. These aren't your standard research drones. The Deep Ninja operates at depths of 4,000 meters, far below the reach of standard active sonar. Equipped with advanced hydrophones and lithium endurance batteries, they can loiter for weeks, forming a silent underwater tripwire. When a Chinese submarine or surface task force moves, the Ninja hears it and beams the coordinates to the surface fleet. The orbital sniper scope. But targeting a Mach 6.5 slug requires insane precision. You can't just aim at a hypersonic missile. You have to predict where it will be in 3 seconds. That is where the QZSS Michibiki satellite constellation comes in. Most GPS systems have an accuracy of a few meters. The Michibiki system, using its L6 signal, provides centimeter-level positioning accuracy, specifically 6 centimeters horizontally and 12 centimeters vertically. This allows the railgun's fire control computer to calculate a firing solution with a margin of error smaller than a smartphone. It turns the railgun from a dumb kinetic weapon into an orbital sniper rifle. The 13DDX Future Destroyer. All of this technology, the railgun, the liquid cooling, the gallium oxide capacitors, is converging into a single hull, the 13DDX. Scheduled for the early 2030s, this isn't just a ship, it is a floating power plant. Unlike current destroyers that struggle to power a microwave and a radar at the same time, The 13DDX is designed from the keel up with a massive integrated electric propulsion system specifically to feed the Railgun's hunger. It creates a multi-layered air defense bubble. Long range, SM-6 missiles. Medium range, the Railgun firing cheap $35,000 slugs. Short range, high-power lasers and CIWS. It is the ultimate cost exchange machine. Japan can sit there and shoot down $5 million hypersonic missiles with $35,000 steel darts all day long. China runs out of money before Japan runs out of ammo. In the end, the US Navy walked away because the math didn't work for them. They wanted a 100-mile offensive cannon. Japan picked up the pieces and built a 20-mile defensive shield. They solved the barrel erosion with new alloys. They solved the power problem with gallium oxide. And they solved the accuracy problem with satellites. The Railgun isn't dead. It just changed flags. And right now, somewhere in the Pentagon, a very uncomfortable meeting is happening, asking the question we all know the answer to. Why did we let them beat us? And listen, if you want to see the US Navy wake up and bring the boom back to America, there is only one thing you can do. Subscribe to Front Cost and smash that like button. Let's make this video so viral that the Pentagon has to watch it. Stay tuned with us.